Hey class, in today's lesson we're going to talk about properties of exponential functions, which is found in section 7-2 part 2 of your book. Our objective is going to be to graph exponential functions that have base e. Alright, so some vocabulary first. It says natural base exponential functions are exponential functions with base e. These functions are useful for describing continuous growth or decay. So if it has a base of e, right, really what we should see, e itself is about 2.7182, and specifically this graph is supposed to be continuous, but e, what you need to understand, e is irrational, because notice that I said about, so that's not even the exact value, that's about 2.7182. What else is irrational, right? Don't forget, pi is irrational, so seeing e should feel just as similar as seeing pi, right? Because we know pi is about 3.14, right? Obviously more digits than that, but we're not going to write them all. So again, when you see e, don't get freaked out. Don't think anything crazy. E is just an irrational value, right? Or an irrational base, but we really only use it for exponential functions to show continuous growth. All right, so we're not going to use it or deal with it too much, but you do need to kind of be a little bit familiar with it. So here we go. All right, so the first one is that we're going to sketch the graph y equals e to the x. Honestly, literally all we're going to do is throw this into the calculator, okay? So once you type that into the calculator, the main thing that you should see is that at zero, your value is 1. So again, at 0, your value is 1. And then really from there, it's just going to be an exponential one from there. So it's really just going to go right up from here. So that's a good enough sketch. So as long as you can show me that it goes through the ordered pair 0, 1, that's good enough for me. Okay. And then if we were to try to find e to the third, okay, all you have to do is type it into the graphing calculator and you get about 20 let's round it to the nearest 100, so that's 20.09. Okay, because again, e is about 2.7182, right? So think about that. Something that's almost 3, right, raised to the third power. Well, if it was 3 to the third, that would be 27, right? If I round it down to 2, 2 to the third is 8. Well, 20.09 does fall between 8 and 27, but obviously since 2.7182 is closer to 3, that means the answer is going to be closer to 27. Okay, so this actually does make sense as the answer to this problem. All right, let's go ahead and do the try. Very simple. On the try, all we're doing is typing this into the calculator. So when you type in e, the caret symbol, and 8, e to the 8th power is going to be about, and I should use about, sorry, is about 2,980.980, sorry, 0.96. So 2,980.96, because again, we should be rounding to the nearest hundredth. All right, that was enough about natural base e for exponential functions. And again, just remember that e is irrational. It's just like seeing pi as something that's irrational, right? A number that's going to keep going on and on and on forever. Okay, but that's all we need to know for now. All right, so now we move on to a little bit of vocabulary. It says a formula for continuously compounded interest uses the number e. So compounded interest, by the way, we use in finance, right? So we're actually going to use e to show continuous growth, right, of something that has been invested, right, into some type of account. Okay, so let's see what that looks like on the other one. And by the way, do take note, right, this A of t is the amount in the account at whatever time t. P is the principal, so your starting balance. You have times e, which we know e is at about 2.7182. The interest rate has to be annual, right? So if they give you something in months, you need to know what that is in years, right? And then lastly, it has to be time in years. So these last two are connected by years. Very specific there. All right, so let's take a look. All right, so in example 5, We're talking about continuously compounded interest. So it says, suppose you won a contest at the start of fifth grade that deposited $3,000 into an account that pays 5% annual interest, compounded continuously. How much will you have in the account when you enter high school 4 years later? Express the answer to the nearest dollar. So again, this is A of t equals P times e to the RT. Okay, P, which is the principal, is going to be the starting amount, which we found here as 3,000, times E, remember that's our irrational number, about 2.7182, right? R is the rate, all right? And remember, it has to be the annual rate, which nicely they tell us it is the annual rate, but you need to change that 5% to a decimal. And we should know that as a decimal, 5% is 0.05 times the time, right? We know that it's 4 years, all right? Order of operations would say that you need to find what 0.05 times 4 is. And once you find that answer, you say e to that answer and then times 3,000. By the way, 0.05 times 4 is 0.02. Or excuse me, 0.2. And e to the 0.2 times 3,000 is about 3,664. So no, it's not like a lot of difference, right, from the time you put it in the account at $3,000 to 4 years later, which is 3,664. But it is still growth, right? So let's go ahead and try the next one. All right. Now it says about how much will be in the account after 4 years of high school. Okay, so at this point, not much has changed. A of t is going to equal P times e to the RT. T, though, has changed, right? So remember, they got this money at the beginning of fifth grade year. So if you think about a full school year, and now we're talking about after 4 years of high school, so now we're talking about senior year. Really, you're counting the fifth grade year. So 5th, 6th, 7th, 8th, 9th, 10th, the 11th, the 12th grade is really 8 years later. So the principal is still 3,000. E, the rate is still 0.05. And the time is now 8. All right, so this is going to be 0.05 to the 8th power, or times 8, is really 0.4. And then e to that 0.4 times 3,000 is about $4,475. And now that makes a huge difference, right? So originally it was 3,000 and now it's gone up to $4,475, so almost $1,500 more. Now remember, when it was just 4 years, it had barely grown $600, right? You add another 4 years to that, and now from the original amount, it's got a $1,500 growth. So it's actually, this is kind of like what people use for retirement, this formula. So the best thing that can kind of help something with compounded interest is time. Time is the best factor in your hand. Also, increase of the principal. Just a little financial tip. All right, guys, that is it. Remember, if you have any questions, please come see me for tutoring.